In the bustling village of Mechanica, there was an inventor named Ella who loved solving mysteries of the physical world. One day she was working on her latest project when she came across Newton's third law of motion, expressed by the equation F action equals minus F reaction. Ella pondered over this equation, which states that for every action force, there is an equal and opposite reaction force. She wanted to see this principle in action, so she decided to conduct an experiment. Ella built a small rocket with a simple propellant mechanism and invited her friend Max to help. This equation tells us that when our rocket fires, the force it exerts on the gas will be matched by an equal and opposite force exerted by the gas on the rocket, Ella explained. Max looked intrigued, but still uncertain, so Ella set up the rocket in her backyard. She carefully lit the fuse, and as the propellant ignited, a burst of gas shot out of the rocket. Immediately the rocket propelled in the opposite direction of the gas, zooming across the yard. Max's eyes widened in amazement. So the rocket moves in the opposite direction because the gas pushes back with the same force. Ella nodded, smiling. Exactly. This is Newton's third law in action. The rocket pushes on the gas, and the gas pushes back with an equal force in the opposite direction. To make it clearer, Ella then grabbed a balloon and inflated it. She let it go without tying it, and the balloon shot around the room as the air rushed out. "Look at this," Ella said. "The balloon moves in the opposite direction of the escaping air." "This is the same principle," Max laughed, finally understanding. "So every time the balloon exerts a force on the air exerts an equal and opposite force on the balloon." Ella agreed enthusiastically. "Exactly. That's how we see Newton's third law at work in everyday life." From then on, Max and Ella used the equation F action equals minus F reaction to explain the mechanics behind their experiments, making their discoveries in Mechanica both fun and enlightening. And so, with a newfound understanding of forces and reactions, they continued their adventures in physics, exploring how every action truly has an equal and opposite reaction.